In this segment, we will discuss the competent host for transformation in the recombinant DNA technology. Right? Transformation means a process in which the plasmid carrying the gene of interest is inserted into the host cells. Right? So plasmid carrying the gene of interest is inserted into the host cell is what we call it as transformation. Now whether the bacteria is capable or is able to take up the DNA, that is able to take up the foreign DNA that is present in the form of plasmid or not. If yes, then there is no problem. If no, then we have to artificially make that bacterium cell competent, make the bacterial cell eligible to take up the foreign DNA molecule. We know that DNA is hydrophilic molecule. Right? DNA is hydrophilic molecule and it cannot cross the hydrophobic membrane. Which membrane I am talking about? I am talking about the PM, that is plasma membrane, not the cell membrane. So we need to make the bacterial cell competent to take up this DNA, that is a foreign DNA molecule. In order to make bacterial cell or bacterium competent to take up the foreign DNA molecule which is present in the form of plasmid, various methods are available. They are categorized as chemical methods and physical methods. Right? So first we will discuss chemical methods. How to make a bacterial cell competent to take up the DNA. Right? In the chemical method, if say for example if we are using the cell wall, if the plant cell is there as a host, right? First of all, host can be prokaryotic cell. Let us say a simple bacterium. E. coli can act as a host. Eukaryotic cells. Eukaryotic includes animals, plants as well as fungi. So eukaryotic includes animal cells can also act, plant cells as a host, then fungal cells. The most common fungi is used is eukaryotic unicellular fungi, that is yeast. Saccharomyces cerevisiae. S. cerevisiae is the most common fungi which is used in recombinant DNA technology under the category of fungal host. Right? Now let us discuss the methods. First is chemical method. Say for example we are dealing with the plants. Plants have cell wall, plants have cell membrane. We need to break the cell wall. So the cell without cell wall is we call it as protoplast. So cell without cell wall is called as protoplast. So what we will do, we will take this protoplast and we will treat the protoplast with divalent cations. And the most common divalent cations which are used are Ca+2 ions. And the source of calcium ions is CaCl2, that is calcium chloride, which is the most common source. So first we have removed the cell wall. It is called as protoplast. Protoplast we have taken, that means the cell membrane is intact. Right? Treating the cell, that is cell with the cell membrane, that is in case of the plant cell, with the divalent cations like Ca+2 ions. And the source of Ca+2 ion is calcium ions. Right? Afterwards, this is the first step that we have done. This is the second step. Then the third step, we will provide heat. So were placed on the ice block, normal protocol. Afterwards, from ice block, they are transferred to a chamber where the heat can be provided, and the temperature that is provided is 42 degree Celsius, which is not about 37 degrees Celsius, right? It is 42 degree Celsius. So at this temperature, using divalent ions like cations CaCl2, which is providing calcium ions, it increases permeability of the plasma membrane. So permeability of plasma membrane is increased. When the permeability of the plasma membrane is increased, plasma membrane can easily accept foreign DNA because we are providing the heat to it, right? So initially what we have done, cell wall was removed from the cells. Cell without cell wall, we call it as protoplast. Treat the cells with the divalent cations like calcium. Source of calcium is calcium chloride. Provide heat to the cells, that is transfer of cells from the ice blocks to heat. Again for few seconds, provide the 42 degrees Celsius, transfer it to the ice block. From ice block, again transfer it to 42 degrees Celsius. In that way, the permeability of plasma membrane will be altered because the major factor for permeability is Ca+2 ions. Other than that, you can also treat the cells with PEG, polyethylene glycol. Treat the cells with PEG, PEG, that is polyethylene glycol. Right? So protoplast with the gene of interest is incubated with the PEG, and automatically the cell will take up the DNA of interest. Right? So these methods can be treated as vectorless methods also, which we will be discussing now, can be treated as vectorless method for the DNA or the gene of interest transfer, because here we are not using any vector to transfer the DNA. The second is biolistic method. Biolistic method is basically, many reference book it is also written as gene gun method. Gene gun method. So basically within that gun, DNA is coated with either gold or tungsten. So DNA is coated with gold or either tungsten because they are inert molecule, they are non-reactive in nature. So say for example, if this is the DNA molecule, this DNA molecule is coated with non-reactive or inert molecule, a layer is prepared that is either gold or tungsten. So basically they are acting as the bullets, and the size is approximately 1 to 2 micron in size. So they are acting as a bullet. Bullet contains DNA coated with either gold or tungsten, which are non-reactive metals. And using the gene gun, they are shot at a speed of 1400 feet per second. So shot at speed of 1400 feet per seconds has been done. Now this speed has to be maintained. Size, it is 1 to 2 micron. 1400 feet per second should be the speed of that one shot, and within that one shot the DNA must enter into the target cell. Now why this 1400 feet per second size is maintained, should be maintained, because if the size is beyond 1400, the shot speed is 1400 feet per second, then DNA will be transferred into vertical cell. But if it is more than 1400 feet per second, from the opposite side the DNA will be released from the cell, it will come out. That is case number 1. Case number 2 is if the speed is less than 1400 feet per second, then it will reach to the target cell, it will fall down. It will not enter into So 1400 feet per second is must. Then third method is electroporation. In the electroporation, electric current at a very high voltage for a short period of time, for a few seconds, it is provided. Then, because of this electric voltage, the pore membrane will become highly porous. So there are minute pores which are created within the membrane for a very short period of time, and through that pore, DNA can easily enter the target cell. So in the electroporation, so cells are incubated in a medium or in a media that is actually, of course, a neutral medium, and then electric current with high voltage, very high voltage for a very short period of time is applied, and because of this, minute pores are created in the membrane. When the membrane becomes highly porous for a fraction of seconds, then DNA from that pore can easily enter into the cell. Then fourth method is basically the micro injection method. One more thing, this bioelastic or gene-gun method is appropriately or widely used for plant cells. It is mostly used for plant cells, and this micro injection is generally or widely used for animal cells, like when we are doing IVF technique or like that, using the zygote or the egg or the ovum cell, we need to insert the sperm directly into the nucleus of the ovum. So micro injection, actually it is very simple, but it is tedious also, right? So in micro injection, it is basically an injection which has some structure like this, and there has to be a perforation where we can hold the DNA of our interest, and using that injection directly, the target DNA, that is foreign DNA, is inserted into the target of the host cell. It is tricky also, but it is widely used for animal cells. So this is all about how to make the host cell competent to take up the DNA using this process, and all these are various vectorless methods for gene transfer.